Hi everyone, and welcome to our video on Spearman's rank correlation coefficient. This is part of our Module 4 Part 3 series on classification and evolution, and we'll be looking at specification reference M1.9, so another one of those maths references. And this is the one where we're selecting and using a statistical test. When it comes to Spearman's rank correlation coefficient, what we are doing is using a statistical test to see the strength of correlation between two sets of continuous data. So if we're trying to identify how closely correlated two data sets are, Spearman's rank is what we would use. What we've got here then is the formula for Spearman's rank correlation coefficient. As with all of your stats formulas, this will be provided for you on your exam paper in the exact question that you need to use it in. The bit they're not going to tell you is in the box, what it stands for. So once again, we're going to make sure we understand what these different bits actually mean, so that when we get this question on an exam paper, we actually understand it and therefore can use it easily. So RS, the rank coefficient, or Spearman's rank correlation coefficient, equals 1 minus 6 times the sum of d squared, and d is the difference between our ranks, divided by n times n squared minus 1. N is just the number of pairs of values. Before we delve into the actual calculation, let's remind ourselves that when we're doing these statistical tests, we need to have a null hypothesis in mind. So the null hypothesis for Spearman's rank is that there is no relationship between the two variables. In terms of how we actually calculate Spearman's rank correlation coefficient then, first thing to do, rank your two sets of data. Literally look down that column and then you're just going to identify the highest, give it number 1, then the next, number 2, and so on. When we're ranking, if we've got two pieces of data that are the same, then what we're going to do is add those two ranks up and then divide it by 2. If you had 3 ranks that were same, you would add 3 ranks together and divide by 3. So for example, if we had ranks 3 and 4 were both the same as each other in terms of the values, all we do is 3 plus 4, which hopefully we know is 7, and then we divide that by 2. So both of those will be given the rank 3.5. What we then do is we calculate the difference between the two ranks. You square those differences, add all those d squared values together, and then substitute it into the formula they've printed onto your question paper. So this is the kind of table you would end up with. When you get one of these questions on the exam paper, they may give you purely these first 3 columns, for example. You can then add all the other columns to the side. There's always space. They might be generous and actually give you some bits of this already printed, just without obviously all the bits filled in. So whenever you get Spearman's rank, add in any extra columns you need to. Okay, that's part of your working out. So if we have a look at our light intensity, and we'll just use this one as our example, we need to find the highest one first of all. So looking down, we can see that 700 is the highest, so we give that rank number 1. We then come to 650 is rank number 2, 600 for 3, 500 is 4, 450 is our 5th rank, and 400 is our 6th. So all we've done is we've literally gone through, found the highest, given it position 1, and worked our way through. We do the same thing for the percentage plant cover, and we write their ranks in the next column. We then work out the difference between them, so 3 minus 4 gives us minus 1, etc. And then we square those differences. What we're then going to do is obviously add up a total of all of these here. So 1 plus 1 is 2, plus 25 is 27, 28, 38, that is 44 in total. So the sum of d squared is our 44. Once we've obviously put that into the formula, we've done our calculation and we've got our value, what we then need to do is compare that to, and depending on the style of question, either a critical value table or the value they said to compare it to in the question. And the reason we're comparing it to this value is to work out if there's a significant correlation or not. If we're using a critical value table, make sure you're reading the row for the right number of pairs of measurements. So in our case, we had 6 pairs of measurements there, so we'd read across the row that had 6. What we then find is we will have a value, our critical value, that we are going to be comparing our calculated value to. If our calculated value is higher than the critical value, there is a significant correlation. And what you're going to notice is you may have a positive or a negative sign on your actual calculated value, and that just tells us whether it's a positive or a negative correlation. If obviously your calculated value is less than the critical value, there is not a significant correlation, and therefore we're accepting the null hypothesis. One thing I will say about all these stats tests is when you are carrying them out in an exam, please do show you're working. Don't just chuck it into your calculator and then just write a final answer down, because one teeny tiny typo costs you all the marks in that scenario. If you've actually worked through, shown you're working in the question, then we can spot where that silly error occurred and you still get some of the marks for the question. You won't get them all, but you'll get some. And that's always going to be potentially the difference between one grade and another. The other bit I will say is please write it clearly. Don't scribble things in random places. Add the extra columns to the table by all means, but then actually substitute it into the formula in the answer space clearly so we can see what on earth you are doing. Make your examiner's life easier because it makes it easier for them to then find the marks for you, okay? And don't forget, when we're actually writing our little conclusion, make sure we are using these phrases. State what your calculated value is and whether it's higher or lower than the critical value of, and then follow that up by saying, therefore there is or is not a significant correlation. So make sure that you are really being explicit in what you say to secure those marks. As always, I hope you found this video useful, and of course don't forget to subscribe to the channel so you can see when the next video is uploaded, and head on over to the website where you can find a range of other resources to help you in your A-level biology studies.